This conference will now be recorded.
Hello. Hello. Am I audible? Hello.
Yeah, Pankaj, you are audible.
Actually, I am not able to hear Ashok.
Oh,
Is it
yeah, same here.
given or
Same.
oh,
No, same
same?
here. Yeah.
Okay. Okay. Okay.
Guys, are you able to hear? Hello, I'm audible. Gaurav?
Yeah, Rohit, you are audible.
Yes. Yes.
Okay, okay.
Rohit.
Yeah.
Yes.
I think you guys also not able to hear Ashok, right?
Mhm.
Yes,
Right,
yes, we
right.
are also.
Yes. Okay, okay. Thank you. I thought there is some connection with my internet.
Oh, okay. Let me stop recording.
Now you are audible, Ashok.
This conference will now be recorded.
Okay. So, guys, we were discussing about map site join, and this is the
Sorry, Ashok,
second
are you
category of.
sharing something? Are you sharing your screen? So your screen is not visible.
Okay. I thought I have shared. Okay. Is it visible?
Yes, yes. Now it's visible.
Okay. So, guys, in previous session we were discussing about map site join. That is second category of optimization, or that is coming inside the query level optimization. Query level optimization is nothing but once we are having the tables and we are trying to fetch certain data from those particular tables, then we are going to apply query level optimization. Inside query level optimization, one of the technique is map side join or map join. In map join, what is happening? We are going to broadcast the smaller table map side join, map side join or map join. So over here, what is happening? We are having two tables, two or more tables, two or more tables, or more tables. One table is smaller, that can fit inside the memory of node. Okay, and second table is the bigger table, bigger table. This is the condition once we are going to apply map side join or map join. One table, it must be small so that it is able to fit inside the memory of a particular node, and then it will be, you can say, once it is broadcasted to each and every node, it will be fitted, it will be able to fit inside the memory. And once that particular table, this smaller table is available locally, then we will be able to perform the join. And this type of join, such type of joins are not having the reducers. And once we are not having reducers, then definitely what we can say, we are not having shuffling, sorting, and function will not be working over there, and we will be able to have the optimization on top of those particular tables. That is perfectly fine. In order to move with this particular approach, or in order to get the understanding about map site join, what we have identified this particular flow. Let me copy or paste and paste it over there. So, with respect to this particular flow, in order to get the understanding about map site join, what we are having two tables, orders and customers tables. These tables are placed inside MySQL database. Okay, these are placed inside the RDBMS MySQL. Then what we are trying to do with the help of Scoop, that is data ingestion and export tool. With the help of this, we are pushing this particular data or ingesting this particular data inside the SDFS. SDFS is nothing but the storage layer of Hadoop ecosystem. Okay, Hadoop distributed file system. Now, after like performing the ingestion, the data is available inside the Hadoop cluster. Then what we are going to do, we are going to create tables on top of this particular data. And once we are having tables, then we will be going to perform the join. Okay, so up to over here, creation of the Hive table, that is the normal functionality. Yeah. After this, we will be trying to apply the map site join. That is nothing but like once we are having the tables, and on top of those particular tables, we are trying to fetch certain data, then we are going to apply map side join. And what we have seen, uh, if we are this particular property map side join is enabled by default. It is enabled by default because system is smart enough in order to do the optimization on top of your queries. First, it will try to check the smaller table. If this particular table, if the system is able to broadcast this particular table into all of the nodes, then it is fine. It will proceed with map side join. If this particular table is bigger one, then what it will do, it will proceed with the normal join. That is the normal functionality. Yeah. So system is also trying to perform the join. That's why by default this particular property is enabled. This is the property. Okay, this is the property. By default this particular property is true, and if you are going to set it to false, then normal joins will be working over there. Map side join will not work. So in our previous session, what we have done, we have ingested orders and customers tables into the HDFS. So just have a look. This was the statement that this was the query that we have executed in order to ingest the data from MySQL to HDFS. So over here, what you are able to see, orders table and customers table. These tables are placed inside MySQL in retail DB. That is the database. Inside the retail DB database, we are having customers and orders table. And where we are trying to put it, we are trying to put it inside the user Cloudera and advanced Hive. Okay, user Cloudera advanced Hive. Let me copy this and try to check it. So Hadoop fs hyphen ls. Okay, and just have a look. So we will. Okay, so we will be having orders and customers. Orders, so customer is not available. So we have not executed, I think, the customer one. So let me do the execution of this particular uh, table as well. Let me try to ingest this customers table as well inside this particular path. Then we will be having orders and customers table. Okay, so scoop import this one and let me have the execution. So from retail DB, what it will do, it will try to dump the data into user Cloudera Advanced Hive. We will be having the directory over here with orders and customers. Orders directory will be having the data with respect to the orders table, and customers directory will be having the data with respect to the customers table. So this is with respect to the ingestion. Like we will be having ingestion, and over here we are able to see map reduce. So scoop is not having reducer, so we will be having reducer less job over here. By default, four mappers are working over here. If we are not mentioning anything, then four mappers will work. If you are going to increase the mappers and all, so you can num mapper is a clause over here that you can apply. We are not going in detail with respect to scoop, but the main thing is that we are trying to ingest our tables inside the HDFS. That will be the first step. Orders table and customers tables, these are the two tables, and with the help of scoop data ingestion tool, we are trying to dump it inside the HDFS, Hadoop distributed file system. Okay, so just have a look over here. What we are able to see, the query has been executed. Now we will be able to see the customers directory as well, that will be having the customers record, customers table record. So just have a look. We will be having four mappers, four mapper file over here for partition, because we have not included the num mapper clause inside once we were performing the ingestion with scoop. Just have a look. So I'm just trying to get what is available inside the orders. Okay, so it will be having four files: 1, 2, 3, 0, 1, 2, 3. So these are the four mapper file, and these files are having the records with respect to the orders table. Just have a look. So let me show you the records: cat and part one. Okay, just have a look. These are the records from the orders table. In the same fashion, we will be having the records from the customers table. Okay, customers, not customer, customers table. Okay, okay, so these are the records from the customers table. Same can be checked inside MySQL. So over here, this is the input. This is the first record with respect to from the customers table, and this is the first record from the orders table. Same we are able to see over here. Okay, so customers records from the customers table, and inside the orders we have seen the records from the orders table. So what exactly is happening once we are performing the ingestion with the help of scoop, so you can focus over here. Say we are having a table that is having say 12,000 records. 12K records was there, 12K records. And what exactly is happening? Say we have not defined no mapper, num mapper, num mapper equal to say data num mapper. So this is a clause. With the help of this particular clause, we will be able to increase or decrease the number of mappers. If we are adding num mapper 8 clause, then we will be having 8 partition files over here. Inside this, we will be having 8 partition files. So over here, just have a look. We are having four partition files: part m 0, 1, 2, 3. So these are the four part file. That is because default mappers are four. Now mappers clause of this clause, we can increase or decrease the number of mappers. Mappers. If we are not mentioning anything, then it will take by default four mappers. Four mappers. Okay, so by default four mappers are there, although like you can increase or decrease the number of mappers. That is perfectly fine. Okay, with the help of this, we will be able to have the ingestion of our records into the HDFS. Now inside HDFS, we are having these particular files. We are having these particular files. Now what we need to do, we need to create the tables onto top of this particular data. Okay, so we are moving with the step number 2. Okay, at this particular stage, what we have done, we have ingested orders and customers table inside the HDFS, and the command is very simple. We have just mentioned like this is we are going to perform over here. We are going to perform the scoop import because we are ingesting the data. If you are trying to export the data from SDFS to RDBMS, then scoop export is the command. So over here we are performing the ingestion from where? So we need to connect the MySQL. Okay, and MySQL is having retail database, retail DB. Username and password is this one. We need to take orders table and warehouse directory. So we are having this particular direct directory where we are going to put the records of this particular table. In the same fashion, we are going to put the records of customers table into this particular directory. What will happen once we are going to use this particular warehouse directory clause? So it will create a directory with the table name, and in that particular directory we are having the records. So what it has done, it has created the tables with orders, and it has created the directories with orders and customers name. So this is the orders table, this is carrying the orders table record, this is carrying the customers table record. Perfectly fine, we are able to have the ingestion of our data. Now we are going to create the table onto top of this particular data. So in order to create the tables based upon this particular data, what we are going to do, so let me try to copy the records first. This is from the customers table. Step 2, creation of orders and customers table. Customers table in Hive. Customers, so creation of Hive tables, what I can say, from orders and customers table data, that is placed in HDFS. Okay. Okay. Now we are going to create the Hive tables. This is the data, and I think this is the customers table. Let me try to check it. Orders, customers. This is the customers one. Let me copy a record. Okay. This is the customers three. Okay. This is the customers table. Table record and orders table record. So I'm going to keep one record in order to create the schema. Okay, so just have a look. Okay, copy and paste it over here. Now I'm going to create the tables. First I'm going to create the customers table. Okay, and then I'm going to create the orders table. So as the data is placed inside the HDFS, so what I'm going to do, I'm going to create the external tables over here. So create external tables and say data, customers data, that is the table name, create external table, customer data, and say customer ID, that is also integer type. Okay, then what we are having, customer first name, or let me mention first name only, first name that is of string type, last name that is of string type. Okay, then okay, what I can say, okay, customer first name, last name, customer email. Customer email, that is of say string type. Then customer password, that is of string type. Then customer street, okay. So what I'm going to do, I'm going to create the Hive tables on top of the data, which is placed inside HDFS, city, state, and zip code. City, state, and zip code. So all of these records are of string type. Okay, string type, row format delimited. Fields are fields terminated by fields terminated by, you can see over here, fields are terminated by comma. Okay, so fields terminated by comma, stored as text file, text file, and location, we just need to mention the location. So location of this particular table or files, the location is this one. So location is this one, and this is with respect to customers table. Okay, so this is the location. And okay, so what we are doing over here, we are creating a customers table. Okay, and that is having data which is placed onto this particular location, and the records are terminated by comma. So this is nothing but simple schema on top of the data which is placed over here inside the HDFS. Data a database batch 32, and inside the batch 32 only we are going to create the customers data, that is nothing but an external table which is created on top of the data which is placed onto this particular location. Now show tables. Okay, so we will be having the customers data and describe formatted customers data. Okay, customers data, customer data, not customers data. Okay, so just have a look over here. This is nothing but the external table. Okay, and this one is the schema with respect to this particular table, and the location of the data, what it will be, user, Cloudera, advanced, Hive, and customer. Perfectly fine. Now we have created an external table which is taking the data from this particular location. And and what I'm going to do, select star from customer data limit 1, and just have a look, we are able to see one record. Okay, so we have not done the ingestion over here, or like we have created a table, Hive table, on top of the data which is placed inside the HDFS. Over here, you just created a table, we just created a table on top of the data. Just we have not performed insert and all over here. Insert into table and all that particular stuff is not performed. Certain data which is placed inside the HDFS, we have just seen the schema or the columns of that particular data, and we have created the tables, Hive table, and it is working perfectly. We are able to see the records as well. Let me try to visualize it in a better way. Okay, so just have a look. This is nothing but the records which we have seen in the customers table. And these are the same record what we are able to see inside the MySQL. Okay, customer ID, first name, last name, same records are available over here. Okay, fine so far, friends. Fine so far, all of you.
Ye- yes, yes, Ashok.
Perfect. I want
Yes,
input
Ashok.
from each.
Yes, yes.
Yes, Ashok.
Perfect.
Correct.
So we have created a table on top of the data which is placed inside the HDFS, and this is the schema, okay, that we have defined in order to create the table. Perfectly fine. We are having we have tested it as well. We have tried to fetch the data from that particular table. Now this is the Hive table, and records are distributed among the different machines. Inside the MySQL, this particular table is uh, available on single machine only, but now this is the Hive table, and it might be possible the records, the files which you are able to see over here. Okay, it might be possible these particular files are placed onto the different machines. Okay, say you are over here you are able to see these particular partitions. It might be possible these particular partitions are placed onto the different machines, but we are able to get all of these particular inputs, and we will be able to create the tables on top top of these particular files. Okay, this is the beauty. Like the MySQL is utilized in order to have the analysis on less amount of data. But once the data is used, then we can leverage Hive, which is nothing but distributed computing framework, analytics framework. Okay, so we have created the customers table. Now we are trying to create the orders table as well. So orders table, let me try to copy this one, and let me paste it over here. So this is nothing but orders data, and this is nothing but orders, and with respect to this.
Ashok,
Yes, yes,
hello.
yes, please. Yes, yes, please ask.
Just one to one thing, like we are moving the table from MySQL to the HDFS via scoop. But the thing is here, we can do this way as well, now from the local system. Suppose if we having the raw data, we can use the put and put the command, and we can like shifting the data on HDFS, and after that we can create the schema based on this extra. Same way we can do as usual, like.
Yeah, definitely you can do. This is like to give you some. This is like why we have moved with this particular approach. I'm trying to give you certain flavor of this scoop tool.
No, what
Okay.
is the benefit here if we can go with this? Is there any like
Basically,
benefit?
in your day-to-day work or in your future organization, what will be happening? There will be certain ingestion tools. Over here, say we are using Scoop.
Mm-hmm,
It might be possible you are going to utilize NiFi. Okay, Glue is there. That is the another, you can say, data ingestion tool. So you need to leverage a particular tool in order to have the ingestion of a particular files, and you need to place that particular data inside the data lake.
mm-hmm.
Right?
Okay, okay, okay,
Okay,
got it.
so it is not like you are playing with one machine only, and you are having certain data onto your local, and you will be placing that particular data into the HDFS. Okay, that will not be the case. So you will be having one machine, Okay, that machine will be communicating with the cluster, and you will be having another machines or servers. From those particular servers, what you need to do, you need to fetch the data, sorry, and dump inside the cluster. Then you will be able to do the analysis on top of your data. It might be possible you are having n number of servers, 10 servers, 20 servers, from where you need to fetch the data and put it inside the data lake. That is nothing but HDFS, right? Fine.
Yeah, so fine.
Okay, so we are going to create orders table. Okay, and with respect to the schema, so what I can say, this is nothing but order ID. Order ID, it is of integer type. Then this is nothing but say order date, and let me take it as a string type only, string. And what we are having, this is nothing but say customer ID. Yeah? Order customer ID, and it is of integer type, and order status. And this is of string type. Mhm. One, two, three, four. 1, 2, 3, 4. So things are looking fine. Okay, we are having these particular entries inside the orders record. Now we are trying to create the orders data table. Let me copy and paste it inside the Hive. Okay, perfectly fine. Now show tables. Okay, so orders data, we are able to see orders data and select star from orders data limit 1. Okay, just have a look. We are able to see the records of the orders data table as well. Okay, so these are the records from the orders data table. Now what we need to do, we need to move with the next step. With this, with the help of this particular flow, what we are able to see, we are having certain tables. Those are placed inside the retail db database in mysql, and we have dumped these particular tables with the help of scoop data ingestion and export tool inside the hdfs. Now, after ingestion, we are having data in terms of files inside the hdfs. Then what we have done, we have created the hive tables. So, and we have checked the data as well inside the hive table. Data is available. Now what we need to do, we need to apply the join. We need to apply the join. So apply join, that means like we are trying to join these particular tables, orders tables and customers tables. So in order to apply the join, okay, what we need to do, we first need to check the property. Yeah, property, this is the property. Yeah, okay, set hive joiner. So by default, Okay, at this particular moment, this particular property is false. It means if I'm going to perform the join, then it is going to have a reducer. Okay, this particular property is set to false, so auto conversion will not work, and by default, like what I have mentioned, it is true, but we intentionally we have set it to false. If we have set it to false, then map side join will not work. Map side join will not work. So in order to perform the join, just have a look. So what we are going to do, say applying the join, that is the third step. Applying the join, applying the join. So say select, and what I'm going to select, say customer id, select customer id, then first name, last name, customer id, first name, last name, and certain stuff from this particular table, say order id, and order id and order date, say, and order status as well. Order status from orders, join customers, join customers data on on what, on what, on or customer data dot customer id, order data, order underscore customer id equal to customer data dot customer id. Customer id is the common field between these two tables. Dot customer id. Okay, so we are trying to select certain columns from these particular tables, and we are going to perform join. Okay, and what I can do, I can do it in this particular way. Limit, say 10. Okay, perfect. Let me try to paste it over here and just have a look. So we are trying to fetch the records from these particular tables, and we have set the reduce the auto convert join. Okay, so this particular property is set to false. This particular property is set to false over here, and if this particular property is false, then system is not trying to do the optimization on top of this particular query, because it is not going to check the small table or big table. It is going to perform, it is going to proceed with the normal join. So over here, what we are able to see, we are able to get records after joining these two tables. And this is the normal join, this is the normal join, and one reducer is working. Number of reducer 1, because the joining column is 1 over here. So 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 this particular job is not a performant one. How we can make it performant one? Just by enabling the property auto convert join equal to true. Okay, so auto convert join, I'm going to set it to true. Okay, and at that moment, what will happen? It is going to do the optimization on top of this particular query. It is going to avoid the reducer, and once reducer is not there, then no shuffling, sorting will be there, and the job will be the optimized one. Okay, so let me mention of over here, if this property, if this property is set to false, is set to false, then system is not going to to check the optimization on top of the query, and reducer will be working over there. Okay, now in order to optimize, we need to set the property to true, then system will broadcast small table, and this job will be the optimized one. Okay, so what we are going to do, we are going to set this particular property to false. So true. Okay, let me set it to true. Okay, copy and paste it over here. Okay, and let me check this, the property value. Okay, now this particular property is true, and now I'm going to execute the same query once again. Okay, so this is the job what we have executed in what we have executed previously, and now I'm going to paste it once again. Okay, so at this moment, the system will perform the optimization, and no reducer will be working over there. And then what at that moment, what we can say, this is the optimized task. Just have a look. So number of reducer, just have a look over here, friends. Number of reducer 0. Previously, it was 1, right? It was 1, and we are able to get the outcome. Okay, so same number of records we are able to see over here, that is coming with the help of this particular job. Fine so far, all of you?
Yes, Ashok, clear.
Yes, yes, Ashok.
Perfect.
Yes, Ashok.
Now what is happening, say this particular property is set to false. This property is set to false. This particular property is set to false. Okay, at this moment, this particular property is set to false. Now, what I want to give some hint to the system that you must try to check with the map site join first, and if it is possible, then proceed with the map site join. Otherwise, proceed with the normal join. Okay, property is set to false, that is perfectly fine. At this moment, system is going to perform the normal join. But what I want to give certain hint inside the system, because say you are sitting over here and you are not having the awareness of the cluster, that what is the value of this particular property. Yeah? Either what you can do inside the HQL query, you first set this particular property to true, perform the execution of your query, and then set it to false or true, whatever, and then you will be able to get the benefit of this particular map site joiner, right? But if you are not having the awareness of this particular property and you are not going to enable it by yourself, then what we can do at that moment, we can provide certain hint to the system. That hint will insist system to check the map site join first, and if that is fine, it is able to, if the system is able to apply the map site join, then you will be able to get the outcome from the map site join with respect to map site join. Otherwise, the normal join will work. So just have a look how you will be able to provide hint to the system. Okay, so let me mention over here, if this property is set to false and still you want to have maps, or if still you want to insist to check for map site join, then in your query you can provide certain hint. So how you will be able to provide hint? So we are having this particular query. Okay, this is the query what you are going to execute. Okay, so hint is available over here, plus map join orders data. Okay, so over here what we are doing, we are going to provide hint to the system. It will try to broadcast this particular small table. If it is able to broadcast this particular table, then you will be able to get the outcome without any reducer. If it is not able to fit this particular data inside the memory, then normal join will work over there. So with the help of this map join, what we are going to do, we are providing hint to the system. This particular property is set to false at this moment, but still we are providing hint to the system that you need to check for map site join first, and if you are able to perform the map site join, then what we can say, that particular job will be the optimized one. Okay, so let me do the execution.
Ashok, what does
Mhm.
this mean? Map join in bracket we have mentioned orders
We
data.
are trying to
That
broadcast orders tables, and that
okay.
is
That
the
mean okay. We have to mention which table we need to broadcast.
yes.
Okay. Okay.
Okay, so one more property is there. Okay, one more property is there. The value for that particular property we need to check. Uh, Ignore map join hint. So I dot ignore map join dot hint. Just a minute. Okay, ignore map join hint. Ignore true. That means it is going to ignore the hint. So what we need to do? We need to set it to false. Okay, map join hint false. Okay, now it's fine. No? So so we are having this particular property map join. Map join by default for this map hive ignore dot map join dot hint. So by default it is set to true. Ignore map join hint. If we are providing hint over here, then the system is going to ignore because of this particular property, right? Guys, are you able to understand? So ignore map join hint. This particular property was set to true. Okay, and if we are providing hint at this moment, then system is not going to take those particular hints. It is going to ignore those particular hints. So what we need to do? We need to set it to false. So the system will accept our hints. So I have set it to true. By default it is also, you can say, true, so we have set it to false. Now the system will listen the hints from our side, and at that moment it will try to do or try to apply the map side join on top of the data, and we have seen it over here. Just have a look. So we have set this particular property hint equal to false. So system is going to listen the hint from our side. We have provided this particular hint in our query. Okay, we have provided this particular hint in our query, and now what we are able to see, the system is working without any reducer, and that is nothing but the perfect map side join. Okay, no shuffling and shorting is happening over here. We are able to get the outcome without shuffling shorting, and what we can say, we are getting the outcome with optimization at this moment. Fine so far. Just have a look and ask if you are having any doubt. All of you just have a look and ask if you are having any doubt.
So Ashok, similarly, we can give this hint of map join on a customer table, right? Like with
Yes, yes, you can. You can.
okay, okay.
You can. Okay.
But
Based upon
Ashok,
your.
we have
Mhm.
to keep it in mind na, if customer's table is large table, then
Yeah, you need to have the understanding about your data.
yes,
That is the
yes,
mandatory stuff.
yes.
Okay. Otherwise, you can set the auto convert join to true. The system will take care about these particular things, right?
Okay.
Right?
Yes, yes. Got it.
Okay. So this is with respect to map side join. Now you will be having one exercise. So we are having four types of join. Majorly four types of joins are there. Inner join, left join, right join, and full outer join. Outer join. Okay, let me mention. We are having four types of join mentioned below. Okay, you need to check. You need to check and provide me the output which join is a perfect map site join with a given condition, with any proposed condition. Okay, let me explain it what I'm expecting from your side. Okay, so we are having four types of joins: inner join, left join, right join, and full outer join. With the help of these particular joins, we are trying to join two tables. Now, if we are going to perform inner join is going to do what? It is going to take the matching records from both of the tables. It is going to take the matching records from both of the tables, and at this moment, once you are trying to fetch matching records from both of the tables, can the inner join be the MapReduce join? Okay, so over here we have applied inner join. If you are not mentioning anything, so by default this one is the inner join. So what we have seen, inner join is nothing but map side join. So it is working perfectly. This is the map side join. But what you need to do, you need to apply left join over here, right join over here, and full outer join over here. Okay, and you need to check is it working as a map side join, right? You need to identify is like what about these particular joins, are these particular joins working as a map side join? If yes, then how? If not, then why these joins are not working as map side join? Are you able to get?
Yes, yes, Ashok.
Okay, all of you. So left join, right join, and full outer join, you need to check, are these join working as a map side join or not? Okay, and you need to specify the condition as well. Like if we are having this condition, then this particular join is working as a map side join, right? Map side join is nothing but once we are having no reducer. Fine, all of you, is it fine?
Yes, Ashok.
Okay.
Yeah,
So
what
this is
condition, Ashok, you are talking about? The condition part. Can you please repeat?
condition you need to check. Huh? Say left join is the condition what it will be. So condition with it will be like this. Huh? So over here, what you have seen, huh. So left join. Let me give you a hint. Huh? Left join. Okay. So what it will do? Keep all the records of left table and matching records from right table. Huh? Right table. Okay, keep all the records of left table and matching records from the right table. Now if the left table is small and big table is small, or let me repeat, if the left table is small and right table is big, then what will happen with the remaining records? It means like left join will not be working as a map side join, huh? So the condition is nothing but like which table we need to take as a small table or big table, huh? Okay, so if we are applying say left table, left outer join, left join, so which table will be the small one and which table will be the bigger one? So left table, if we are keeping left table as a small table, then probably you will not be able to get map side join as left outer join, as left join, huh? Fine.
Yeah, clear, clear, Ashok. Thank you.
Okay. So you need to put big table or small table in such a way that this particular join will be the map side join. Okay. So that is with respect to map side join. Assignment you need to check, you need to explore with respect to the assignment. Now moving further, if we are talking about query level optimization, inside map side join what we have seen, if one table is small and another table is big and small table is able to fit inside the memory of a particular node, at that moment we can apply the map side join. At that moment map side join will work, huh? But friends, what will happen if both tables are big? If both tables are big and we are willing to have optimization, then what we need to do? Are you able to get? If both tables are big, then how we will be able to have the optimization? Hmm? Map side join is working on big table and small table. Condition: small table must be small enough to fit inside the memory of node. Okay, so this is the condition for map side join. At this moment map side join will work, but Once both tables are big, then what to do? Okay. At that moment, what we need to do? Okay. So in order to solve this particular issue, once we are trying to fetch the data from tables which are huge in size, then what we can do, we are having two types of joins: bucket map join, and short merge bucket map join. Short merge bucket, short merge bucket. So let me mention over here, this is the first technique inside query level optimization, this is the second one, and this is the third one. Okay, and sometimes it is called SMB, short merge bucket, SMB, short merge bucket, and it is applied once we are having both of the tables in a big size. No table is able to fit inside the memory. At that moment, we can proceed with bucket map join or short merge bucket. Okay, so bucket map join. Let me pick this first one, bucket map join. Bucket map join. So condition for bucket map join, conditions, condition, both tables must be bucketed on join columns. Join columns. Second one is number of buckets in table 1 must be the integral multiple, of table 2. So what is the meaning of this? Say if table 1 is having two buckets, table 1 is having say two buckets, then table 2 can have how many buckets? Four, 4, 6, 8. Okay, it will be nothing but integral multiple. 10, 12. So in table 2 we can have these many buckets. If we are having inside the table 1 we are having three buckets, so inside the table 2 we can have 6, 9, 12, 15. In such a way we will be having, what I can say, these are nothing but the integral multiples of table 1. So this is the condition once we are having bucket map join. Both tables are big, that is the first condition, that is the understood condition. Like once we are not able to apply map side join, that, and the condition for map side join is nothing but like one table, first one table must be small enough to fit inside the memory. Now we are not meeting with the condition, like the table is in big size and we are not able to fit it inside the memory. Now what we can do, we can proceed with bucket map join, and that is nothing but it is applicable once both tables are big. But once we are looking for the bucket map join, at that moment we are having two conditions. We need to satisfy two conditions. First one is like both the tables must be bucketed at the join column. Second one is the number of buckets in table 1 and table 2 must be integral multiple of each other. Okay, if table 1 is having two buckets, then in table 2 we can have 4, 6, 8, 10, 12, these many buckets we can have. And what is with respect to the short merge bucket? Short merge bucket, that is nothing but SMB. Okay, SMB. So over here, the little bit change is there. Okay, so for short merge bucket, both tables must be bucketed and sorted on join columns. That is the first condition. And number of buckets in table 1 must be equal to table 2. Number of buckets in table 1 must be equal to the table 2. These are the two conditions with respect to short merge bucket. So these are the techniques which are coming inside the query level optimization. And in our tomorrow's session, we will be having practical onto the bucket map join and short merge bucket. That's all for this particular session, my friends. If you are having any doubt, you can ask. Anything that is coming in your mind, you can ask. Okay, I will take your queries. Let me stop the recording, then we can proceed.